Okay, hello students. Here I am now back to creating this video to help to complete lesson number 1 and 2. This is unit 2, algebra 2, and I'm gonna walk through practice problem of lesson number 1 and 2. The first lesson is let's make a box. Basically, this is about creating a volume function of a box and figuring out for what value of x will be the volume maximum. Let me go straight away to the problems. First problem of practice problem. So a rectangular schoolyard to be fenced in using the wall of the school for one side. Let's see if this is the school. If this is the school, so one of the side is the wall, right? So this is the wall. And the fence is 150 meter long. Now let's imagine this is the fence, which is 150 meters. This is 150 meters on all three sides. So now you have to make this compound. If this is a compound, I need to make a fence this side and this side, same, which is perpendicular to the wall. And let's see, we don't know how much is that to be taken off. So to be put here, so I'll put x. Let's see, because it says find the area function in square meter of the schoolyard is a function of the length x in meters of each side. That means if you put x meters on the left side and the right side, then there will be this will be here. Okay, so the total is 150. That means x plus x. And what is the other one? It will be 150 minus 2x, right? Because so this will be x plus x 2x. So if I say if this is x this side and if this is x, what the remaining will be. So this part, this fence will be 150 minus 2x, correct? So that means this is 150 minus to the pink color. So write the area function, and the area is length times the width, okay? And the length is 150 minus 2x, and the width is the x, this part, right? X. So that's the area function. Second question is, what is the school? What is the area of the schoolyard if x is 40? That means all you do is put input as 40. That means you are placing 40 meters for this side and you are placing 40. Of course, we know the common sense 40, 40 add to 80 and 150 you take away from 180, 150, and you get 70. So it's basically it's 45, 70. But I want you to write using the expression and say, okay, this is 150 minus 2 times 40 and then x, which is times 40. So that will be 150 minus 80 times 40. That is, this will be 70 times 40. So it becomes 7 times 4 is 228, 2,800. Now, what is the reasonable domain of A in this context? What does it mean? Remember, when you put a fence on either side, that fence has to be greater than 0. It cannot be equal to 0. If it is equal to 0, there's no rectangle formed there. And then also, this pink color 150 minus 2x should be greater than 0. That means 150 minus 2x greater than 0. In other words, you can't put 75 this side and 75 this side. See, it means because if you put 75 this side and this side, then there will be nothing left here. This will be 0 because 75 plus 75 is 150. So common sense says that the amount of fence that you put perpendicular to the wall has to be lower than 75. And clearly this you have to combine and you get 0, less than x and less than 70. Or you can work this out this way and say, okay, subtract 150 both sides. So this goes away, drop down to x, and that will be 150. Then divide by -2, and you get x is, and switch, because you're dividing by negative, you switch the sign of inequality and you get it this way. So that's how you get the domain, the reasonable domain is 0 less than x less than 74. And also we can check with the Desmos here. So you click here. Uh, Did I do it right here? Maybe. Okay, here. Suppose this is a function. It's 150 minus 2x. There you go. And you can see on the right side there is already a graph which you have to adjust. You have to go to the setting, and I'm trying to set the y there. You can clearly see. So when I do some changes, now I want to. There you go, and you can clearly see that's the graph. When x is 0, you won't have a rectangular fence, or x is equal to 75. So the domain is from 0 to 7. These are, in the later classes, you will see they are called the zeros of the function, area function. This is the maximum where the area in the, so the amount of fence that you put on either side, 11, 12, 13, as you increase the width of the fence of the rectangle, the volume, the area goes on increasing. There's at one time the area is going to be, that is 2,812. That's the maximum area that you will see in the next lesson. Okay, let's go to the next one. In the second question, problem number two, this problem number two, the graph. So let me show the problem exactly. Here it is. Nova finds an expression for Vx. So now it speaks about the volume of an open top box in cubic inches in terms of length x inches of the cutout square used to make it. This is the graph of Nova gets if he allows x to take on any value between -1 and 5. Now, what does this basically means is, that means by just looking at it, just watch this. This is 0, this is 2.5, and this is 3.5. Now, when I say 0 is 0 and 2.5, these are the zeros where the or x-intercept, which is 5/2. Okay, and or if you double this, that means if you double this 2.5, so if you double this, become 5, and 3.5, which is the other zero, if you double it, becomes 7. So basically, there is a paper. Let's see, there's a paper which is 5 and 7, and then you cut off a square of length x. So this is x, 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 right? So each of the corner you are taking x, and you get a, and you create a box. So the box will be, so this will be 5 minus 2x, and this will be 7 minus 2x, and the box will be this, something like this. So this will be 7, and maybe this way, and then you cut out x. This is the height, maybe. So you see, like this. So this one, and you get height, and you create a box. So this is 5 minus 2x, and this is 7 minus 2x, and the height is x. So question is, what would be more appropriate domain for this? By just looking at it, you can see so this is 5. So naturally you cannot have more. This is at the most it should be less than 2.5 this side, 2.5, because 2.5, 2.5 adds up. So the domain here is start from 0, less than x, and less than 2.5. You cannot go beyond. If you cross out beyond this, even though this is the graph that is shown is a cubic function, a cubic polynomial function, and how do you get this cubic polynomial function? Is the volume is length times width times height, and the length is the 5 minus 2x, which you see here, 5 minus 2x, and the width is the 7 minus 2x, and then the x. And you can see this thing is a polynomial. If you can easily make it a polynomial function by multiplying x. So first you multiply this part using FOIL method, and then you multiply x and you get the polynomial function. What I did is also try to show the maximum, use the Desmos right here. So here it is. So x 7 minus 2x 5 minus, and that's the maximum. Of course, this is actually the, if you cut out square of length zero point 0.9, almost like 1 inch, then the maximum volume is 15. So this is one of the zeros. That is 2.5. That is 3.5. So this part is the domain, but the maximum. But you're supposed to figure out the volume from the graph itself. So if I take this off here, okay, and clearly, so this part right here, see, it's at 1, almost like 1. So what is the approx? This speaks about approximate. So we say, okay, at 1 there is a maximum. So we say it is 1 when the input is 1. When you cut out x is with 1 on each corners, it means the volume will be 15 cubic inches. So I hope this uh, helps to understand everything, not just visuals are here. There was a paper, you create a box, and the top part is open here. So you want to know when is the volume maximum and what is the domain. The domain is from 0 to 2.5 until 2.5. Hope that helps. Let's go to the next. Okay, this is question number 3. So Mai wants to make a open top box by cutting out corners of a square piece of cardboard and folding up the sides. The cardboard is 10 by 10. So this says you the cardboard is already 10 by 10. So this is 10, 10. So you're taking a piece, you're taking off a square piece of cardboard. So side length X is taken off. So here, so that's how you take it off and you get a square base. So what's going on is if this is x and that is x, this part will be 10 minus 2x. So this will be 10 minus 2x. That means both the length and the width of the box that you are going to say, the length and the width, they'll be the same. So, and then you get x. So we are going to cut like this. You get a box. So this is 10 minus 2x. This is 10 minus 2x. And that is x. So write an expression for the volume of the box created by folding upwards, and when you cut out x length square of length x. So it is volume is length width height. So the length is 10 minus 2x, the width is 10 minus 2x, and the height is x. There you go, you're done. So what is the volume of the box when x equals 3? So all you do is plug in x equals 3, 10 minus 2 times 3, 10 minus 2 times 3, and then 3. So that comes 6, and this will be 6. 10 minus 6 will be 4 times 3, and 16 times 3 is 48. Now this expression I also thought of showing in the Desmos.com. How does it look like? So if I take this off and here I have written down 10 minus 2x because it is twice. Both the length and the width is the same. So I put this is the volume and I can always write Vx this way. Okay. Vx is this and I just want to see the graph. This is how the graph looks like. I can make it smaller uh, this way and I can change this to maybe I want y to be a little higher, maybe 100. There you go. And there it is. So this is 5, this is 0. So the domain is between 0 to 5, and the volume of the box is maximum when the cutout square has length as 1.667. So this is understanding of polynomial function. So this is a cubic polynomial function in the factored form. The zeros are where the x-intercept here. These are the zeros, x equals 0 and x equals 5. And this x equals 5 is twice repeated. So it's repeated means explicitly. So we say it has a 0 with multiplicity 2 because one of the zeros is repeated twice. Question number 4 is just a repetition of what we did earlier. The area of a pond covered by algae is 1/4 of a square meter. So that means 1/4 of a square meter. So it's like 0.25 square meter. So let's see, this is a big pond and there is a little piece here which is filled with algae. I can use a green color for this maybe. Okay, so this is algae, and every day when it doubles, that means on one day, if it is 1/4, the next day it doubles, means you multiply by 2. So when you multiply 2, what is 1/4 was the beginning, and multiply by 2, and you can see 2 divides 4, so it's 1/2. So this become it become 1/2. So that means this doubles. So that means maybe it is this much. Then half becomes 1 multiplied by 2 is 1, and multiplied by 2 is 2, multiplied by 2 is 4, and multiply 2, and so on. That's all they're supposed to figure out to fill that up, and just want to understand that. Then become double, maybe this much, then become more double, and like that. So let's go to the full plot. So here is a table, sequence Pn. So Pn there, and you're supposed to write recursively. So what is the recursive definition using the function notation? Now what's going on is here, it is, if you see this 500 divided by 5,000, and you can see this goes away and you get 1 by 10, and that is 0.1. And it's the same thing if I divide 50. So what it means is if you're every time there's a growth factor of 0.1. So each time you multiply by 0.1 or 1/10 of. So that means the growth rate is here is R. So the function notation is Pn is always recursive. How do you write recursive? Is you need to know in the beginning we had 5,000, so I'll put that 5,000. Okay, and or for the recursive, you always use what was the previous one. So if it is Pn, then previous one Pn minus 1, and time the R, which is this one 0.1. So, and if it is in the beginning, that is P of 1 is 5,000. So in the beginning P1 is 5,000, but at any n, then this is good for greater than equal to 2, because you're already taking care of the first uh, the first term, or step number 1 is already 5,000, and this is good for step number n equals 2, 3, 4. So let's go directly to the next question. Okay, here is the table showing two different places. The sloth population is given. So I can just make x-axis, y-axis. And the population 2, you can see it goes down by 2, so minus 2, the again minus 2. So this is arithmetic progression where it starts with 39 maybe here. And the other one is 90, so start with 90 here maybe. This is 90, just approximately, not perfect. So 39, and that means begins begins at 39. So this may be 39, this is 20, 10, and 30. So, and I have 0 to 7, 1, 2, 3, 4, 5, 6, and 7. So the population 2 is where start with 39, uh, and then 1 is 37, so 37, something like this. And 2 will be this way. So each time, uh, this is not perfect, but I just wanted to show it goes down by like this. But this part is geometric progression, because it starts with 90, and then at 1 it is 76. So if it is 1, It is this, if this is 40, this will be 60, this will be 70. So 76 will be somewhere here. So basically what I'm trying to say is it goes down like this. And at one point it'll be almost same. I'm not going too much detail on this, but what I'm trying to say is uh, the population A is decreasing in a exponential. There's a decay there, but and that you can see this going down. But the other one is there's a linear because it's going down by 2, and the other one is decaying. Okay, this is question number 2. Sorry, this is lesson number 2, practice problem. The first question is polynomial expressions that are equivalent. So this is already given to us. And you can see the degree here is, the exponent here is 4. And what that means is the degree is 4. So this is also called degree of the polynomial. Remember, how do we define a polynomial is anything expression that has a x, and you have to make sure that x raised to this part should be only integers. Integers, but which one? Can be 0, but it can be 0, 1, 2, 3, but cannot be this, right? You can't have this. Or you cannot have a fraction, or you cannot have a square root of x. So these are not polynomials. So make sure that for a polynomial expression, the exponent has to be either 0 or 1, 2, 3, 4. Now in this case, which one is similar? Last week we spent on adding, subtracting, and also you're using distributive properties. Now watch this. Is this equivalent to this? No. So what is that? This is only 16x raised to. You don't see nothing here. You don't see anything there. What about is b exactly similar? So this is 6x raised to 5, and in this expression there is no 6x raised to 5. So this cannot be the answer. This cannot be the answer. What about the next one? Okay, the next one, 6 raised to x, yeah, it is there. 4x cubed, it is there. Negative 7x squared, it's there. 5x, so exactly the same. This is correct. What about d? So to check whether d is equivalent, we have to make sure all those. So 8 is there, correct? 5x also is there. Minus, oh, sorry, I'm doing the wrong one. And if you see here, this 8 is right here, so that's not an issue. Plus 5x, also plus 5x. Plus 7x squared, but this is minus 7x squared. These are not the same. Not the same. So this cannot be. So that means let's check for the last one. Do you think it is plus? Let's check E. So there's a plus 8, plus 5x, minus 7x squared, minus 7x, 4x cubed, 4x cubed. So it does not, so everything is there. So the order doesn't matter whether 6x raised to 4 is in the beginning, this is beginning, and here it is last. But when you write this with the degree in the beginning and then in the descending order, the exponent, can you see here what I'm trying to say is this is a quartic polynomial because there is a raised to the power 4 and then comes 3, then 2, and there's 1. So this is called standard form of writing form to write the polynomials. Let's go to the next one. Okay, the second question is each year a certain amount of money is deposited in an account which pays annual interest rate of R, so that at the end of each year the balance in the account is multiplied by the growth factor. So this is important. X equals 1 plus R, where R is the rate of interest. 500 is deposited at the start of the first year. Now I'm going to make a table for this. What does it mean is there is, let's say I hope I make it nice. Let's see, in the beginning, that's 0 year, that means 0 year. This is years, and this is the total amount, let's see, amount. So 0, 1 year, and 2 year, and 3 year. So in the beginning, he deposits 500. So this is 500. Now this 500, because it gives, I think, where is that? There is one place where it speaks about how much is the, okay, it doesn't tell. So write an expression for the value of the account at the end of 3 years in terms of the growth factor. It means there's a growth factor is x. This one, when you multiply it with this amount, will be 500x. Then again, in the end of the in the second year, so from 0 to 1, after 1 year, that's the amount. After 2 years, you multiply again x, so it becomes 500x squared. Then you multiply another x, so it becomes 500x cubed. So the money which was 500 in the beginning, this is what you get after 3 years. But then you deposit in the end of in the first year here, you deposit $200 at the start of the next year. That means in this case, deposits 200 here. Now this 200, which is right here, will become 200x because you're multiplying by the growth factor. And then here, this will be 200x squared because you're multiplying one more time. And finally, 600 is deposited at the start of the following year. What it means is, so here you deposit 6 years. So the $600. This $600 is kept only for 1 year, so you multiply by x. So this becomes 600x. So all this money will be together. So the write an expression for the account at the end of 3 years. So your answer is amount in whatever that, how many years it is, will be just total this part, which is 500x cubed plus 200x squared and plus 600x. And there is the expression that helps to figure out how much the money will be at the end of 3 years. What is the amount nearest end in the account at the end of 3 years? And if the interest rate is 2%. Now, what is this 2% is the rate of interest, that is R here. Okay, this R is 2%. Basically, it is 2 out of 100, which is 0.02. Now, what is X is 1 plus R, which is 1 plus 0.02, which is 1.02. All you do is you replace this in the over here, all these places. So your A of 1.02 will be 500 times 1.02 cube plus 200 times 1.02 square plus 600 times 1.02. You just calculate this. Now you need a calculator for this, and you'll have to put this on the calculator and you check. You can end up getting 1350.68. Clearly, you can try this using. Yeah, I just thought of showing with the Desmos calculator. You can on your laptop, you can open desmos.com like this and then calculate. 500 was deposited for 3 years, so 1.02 raised to the power 3, and then 200 was for 2 years, and 600 for 1 year, and you'll get the answer of exactly what I said, 1350.68. Hope that helps. So question number 3 is very easy. Consider following polynomial px. So this expression that you see, it is a cubic polynomial. Now why it is cubic polynomial is because here the largest or the greatest exponent here is 3. So the degree is 3. So whenever you have this expression, that is a polynomial. It is the Poly means many, right? So many monomials are combined. Now, what is monomial is each one of them is a monomial. The 5x cube is a monomial. 8x square is a monomial. Minus 3x is a monomial. So what is the definition of a monomial? Is an expression where you multiply a number and a variable. That's all it is. So that is, but when you talk about variable, it should be only x, not x raised to minus 3 and those kind of things. You can't have those expression with negatives. So the monomial is the exponent has to be integer or 0 or 0, 1, 2, 3. So that's I just want to make sure we understand what is a monomial means. And then you combine monomials as many and you can get polynomial. Now the question is asked in this case is evaluate means the value of the polynomial means in this case it is px, right? This is a function notation. So right, so it's represented by px. I could have also called rx or qx. Anything like this is a representation of different expression of polynomials like this. I can have rx as 7x squared minus 8 like this. See? So right now the question is asked, what is the value of for x equals? All you do is put x equals minus 2 right here, p of minus 2. It means you just plug in 5 times minus 2 raised to 3 plus 8 times minus 2 squared minus 3 times minus 2. So you replace x by minus 2. So this will be minus 2 minus 2 minus 2 is minus 8 and times this will be minus 40. This minus 2 will be 4. 4 times 8 is 32. And this will be plus 6 and plus 1. So that then this together will be minus 8 plus 6 plus 1. And you can clearly see 7, you get minus 1 answer. What basically it means is, what does it mean is, it means this is a cubic, right? The cubic is always, graph will be like this, down, up. So this is down, up. So what it says is when x is minus 2, it means here when this is minus 2, the value is minus 1. That's all it is. So, so this is minus 1. So this is the point. So the graph goes through this point, which is minus 2 is minus 1. That's the point. And I don't know how the graph, you can see this as a plus 1. That means it goes through plus 1 also. And maybe something going this way. I don't know. And we have to figure out exactly how. But it means, it only means that when input is minus 2, the output is, when input is minus 2, the output is minus 1. That's all the meaning of evaluate the function. So you want to know what is that point on the graph of the function. So now this is similar type of a problem. An open top box is formed by cutting squares out of 5 by 7. So there is a paper which is 5 by 7, okay, and then you want to cut out a piece x length, side length of x inches at every corner. So like this, it's the same thing we already did. So when you take off x and x, what you left with is 5 minus 2x, right? So this will be 7 minus 2x, and you get a box. Okay, so you get a box this way. And the question is, what is the volume? So they already gave you, look at this, rewrite this equation by expanding the polynomial. All they do is, can you rewrite this? All you do is, you use, let me write this, rewrite x first. I will write x first, then 7 minus 2x, and then 5 minus 2x. You can either use the FOIL method, or there's another method I want to use, the box method. How do you expand this? You make a box like this, okay? And you can see, okay, this is 7 minus 2x. So I'll put 7 minus 2x. And the other one is 5x minus 2x. So you put 5 minus 2x and make a box out of this input. So 5 times 7 is 35. 5 times this will be minus 10x. Minus 2 and 14 will be minus 14, and minus 2 is plus 4x, right? So you get x, and in the inside, this will be 35 number by itself, and this will be square, which I'll put 4x square, and then you can combine this, which I missed here, x here, so negative 14, and that will give you negative 24x. And use the distributive property, this one, so you get 35x, then minus 24x squared, and then 4x cubed. There you go. So you get a nice function, 4x cubed minus 24x squared, and plus 35x, and you're done. That's all you're supposed to do, expanding that polynomial function with the degree is 3 here. The greatest exponent is 3, so we say degree is 3, and the degree is 3. This is called cubic polynomial. So hope that helps to understand what is quartic, what is cubic, and sometimes it is quintic. So if you have x raised to 5 minus 7x cubed plus 4x squared, anything like this will be, I can call it quintic because the degree is so like that. Okay, let's go to the last one. A similar problem was solved in my lesson number 1. Practice problem, same thing. A rectangular playground space is to be fenced using the wall of the daycare. So there's a daycare building, the same thing. This is a daycare, and you want to put a fence right here. Okay. So all they are saying is the total fence is 200. So you put x here and x here. So that becomes 2x. So this will be 200 minus 2x. So the what is the area function will be is ax is the length. So this is that area, length times width. So it is 200 minus 2x and multiply by x. That's the area. And what is the area of the playground when x equal 50? So all you do, you put x is 50 here, and then you multiply 50 here. So this will be 50 times 50. This will be 100 and 50. You can see you get the answer as 5,000. See? What is the reasonable domain? Now remember the domain means your x, the fence that you're putting is has to be greater than 0, and also it has to be, if this is 200 total, I can't put 100 here and 100 there, right? You won't get a rectangle there. So it has to be less than 100 and you're done. So hope this video helps you to understand what is the polynomial, the monomial expression, how to evaluate, how to apply in real life, and all those problems. And I think there's one problem number 6. Let me see. The last problem I want you to try, and it says here, Tyler finds an expression for volume, gives the volume of an open top box in cubic inches. In terms of the length x in inches of the square cutouts used to make it. This is a graph which is the graph itself is shown, and you can clearly see by just looking at it what is the domain and what is the so the question is what will be the appropriate domain they're asking and what is the volume. So I want you to figure it out for yourself by checking on the one that I already did earlier. Okay. See you guys. We will continue with lesson number 3 and 4 next time. Thank you so much. Make sure you write all the steps.